Today we are going to learn about mastering SQLite joins for efficient queries. We will explore various join types in SQLite, understand their applications, and hone skills for optimizing database queries. Welcome to our session on mastering SQLite joins for efficient queries. The concept of joins is integral in the realm of databases, allowing us to retrieve data from multiple tables simultaneously. In this video, we will delve into various types of joins available in SQLite, each serving a unique purpose in data management. By understanding these joins, you'll be equipped to combine data from multiple tables seamlessly, forming the backbone of efficient and effective database queries. Let's get started by exploring the foundational concepts of joins and their significance in database operations. Inner joins are perhaps the most commonly used joins in database queries. They are designed to return rows when there is at least one match in both tables involved. In other words, an inner join focuses on the commonalities between two tables. To perform an inner join in SQLite, we use the inner join keyword followed by the condition that specifies how the tables are related. For example, consider two tables, customers and orders. To find all orders placed by customers, we would join these tables on a common column, such as customer_id. This would result in a dataset that includes all matched rows from both tables. Inner joins are particularly useful in scenarios where you're interested only in rows with matching data, making them efficient for queries requiring precise data retrieval. They help maintain data integrity by showing only related records, making your output cleaner and more relevant. Left joins, also known as left outer joins, are vital when you need to retrieve all records from one table and the matched records from another. They ensure that all rows from the left table are included in the result set, regardless of whether there's a match in the right table. The unmatched rows in the right table result in null values in the output. The syntax for a left join in SQLite involves using the left join keyword followed by the joining condition. For example, if you want to find all customers and their orders, even those who have not placed any orders, you would perform a left join on the customers table with the orders table on customer_id. This query ensures that every customer appears in the result, providing a comprehensive view of your data. Left joins are highly effective for maintaining data inclusivity, offering visibility into unmatched data, and are particularly useful in reporting scenarios where it's crucial to display complete datasets. While SQLite doesn't natively support right or full outer joins, understanding their concepts is important. Right joins are similar to left joins but include all rows from the right table and matched rows from the left. Full outer joins, on the other hand, return all rows when there is a match in one of the tables. They provide a complete dataset by including unmatched rows from both tables, filled with nulls where there is no match. Although SQLite lacks direct support, you can achieve similar outcomes using a combination of left joins and unions in your queries. For instance, to simulate a full outer join, you could perform a left join from table A to B and a left join from table B to A, then combine the results using a union. Understanding these join types expands your ability to handle complex data retrieval scenarios, especially in systems supporting full outer joins, offering maximum data visibility.
Cross joins produce the Cartesian product of two tables, meaning every row from the first table pairs with every row of the second table. This type of join doesn't require a joining condition and is useful in situations where you need to combine all possible pairs of rows from the tables. The syntax for a cross join in SQLite is straightforward. Simply use the cross join keyword between the two table names. It's crucial to note that cross joins can lead to significant performance issues if not used judiciously, especially with large datasets, as they exponentially increase the number of rows in the output. For example, if table A has 10 rows and table B has 5, the result of a cross join will be 50 rows. Cross joins are particularly practical in scenarios like generating test data or analyzing all possible combinations of data. However, always consider the size of your dataset to manage resource consumption effectively. Joins can significantly impact the performance of your database queries. As crucial as they are for data retrieval, improper use or lack of optimization can lead to slow query execution times. To enhance performance, consider indexing the columns used in join conditions. Indexing accelerates data retrieval by providing quick access paths to the data. Additionally, be mindful of the dataset size when performing joins. Larger datasets may require query optimization techniques such as limiting the number of columns retrieved or using subqueries to reduce the data processed in joins. Balancing complexity with efficiency is essential. Complex queries with multiple joins might offer comprehensive insights but could also slow down performance. Lastly, always analyze your query execution plans to identify bottlenecks and opportunities for optimization. By adopting these strategies, you ensure that your join queries are both effective and efficient, allowing you to manage resources wisely while achieving your data retrieval goals.
Understanding joins theoretically is one thing, but applying them to practical scenarios is where true mastery lies. Let's walk through some real-world examples to solidify your understanding. Imagine managing a database for an e-commerce platform. You need to determine which products have been ordered and their respective customer details. An inner join between the orders and products tables on product_it and a subsequent join with the customers table will yield the desired data. Alternatively, you might want to see all products, including those not ordered. Here, a left join from products to orders allows for this visibility. As you craft these queries, consider combining different join types to handle complex data retrieval needs. For instance, you might use a left join to gather comprehensive product data, followed by an inner join to filter specific customer segments. By practicing these examples, you enhance your query construction skills and prepare for real-world data challenges.
While joins are powerful, they can sometimes lead to unexpected issues. Common problems include null values in result sets, which often occur with outer joins. Understanding the cause of these nulls and how to handle them is crucial for accurate data interpretation. Additionally, performance bottlenecks are frequent with poorly optimized joins. Ensure that your tables have appropriate indexes and that your queries are structured efficiently. Mismatched schema, where the columns used in join conditions are incompatible, can lead to syntax errors or incomplete data. Always verify that related columns have matching data types and constraints. By following best practices, such as reviewing query plans and testing joins with sample data, you can prevent and resolve these issues effectively. Troubleshooting joins requires a methodical approach, but mastering it ensures that your queries remain robust and reliable, delivering the data you need without unnecessary complications. As we conclude this session on mastering SQLite joins, it's important to reflect on the key concepts we've covered. We explored various join types, including inner, left, right, full outer, and cross joins, each serving unique purposes in data retrieval. Efficient use of joins not only enhances query performance but also significantly improves your database management skills. Remember, continuous practice and learning are essential to mastering these concepts. As you advance, consider exploring more advanced optimization techniques and expanding your skills further. Thank you for joining us, and we hope this session has empowered you to utilize SQLite joins effectively in your data management endeavors.